thanks everyone for having me. I appreciate the invitation, and thank you to Bryce for his presentation earlier on his project, on the shout out to Atlas and Magic. Um, so today I'm going to talk to you a little bit generically about Atlas, about the Atlas project, about what it's for, how it works, and then give you a tour of the interface. Again, my name is Stefan Suez. I am the front end UX, UI visualization guy for Atlas. So I don't do the back end program. Most of what I do is the front end, but work very closely with everyone collecting the data and doing all the back end stuff. So let me share my screen. Let's see. Can everyone see my screen okay? Hopefully that's yes. Um, so uh, what you see in front of you is the main page of Atlas, what you would get to if you just go there without logging in. Uh, and in order for Atlas to be as useful as it can possibly be, and so that you can make measurements yourself and track those, it's probably best to log in. So I will go ahead and log in with an account. And when you log in for the first time, what you'll see on the Atlas dashboard is you'll see a welcome with your name. You'll see which groups you happen to belong to. In this case, I belong to an ambassador group, but I also belong to a probe host group. That's people who actually maintain and host a probe on their own computers or infrastructure. On the dashboard, you have numerous cards which apply to you and your situation. So generally, you'll have a quick start guide, which will tell you a little bit about Atlas and help you get started with welcome aboard, talking about measurements, analyzing your network, and where to learn more. Any of these dashboard cards you can actually shrink if you don't want to see them, or you could drag them out of the way to some other place. We also have the news card, which tells you about new things that have been released in Atlas. We have a quick look measurements dashboard card, which allows you to make quick measurements. I will show you a little bit about this later because we also have this in the use cases. Here you have your credits card, which tells you how many credits you have within Atlas. In order to run measurements against the Atlas network, you need to have credits. The Atlas network itself is a network of, I think, currently about 16,000 probes. I think they were speaking about it a little bit earlier, but with this network of 16,000 probes, we can conduct measurements against various targets around the internet. We can conduct pings and trace routes and DNS measurements, as well as NTP measurements, and in the case of anchors, HTTP measurements. And by conducting these measurements, we can judge things that are happening about the state of traffic on the internet. If there happen to be bottlenecks or problems or outages or misconfigurations in the setup of internet routing, those are all things that we can test through measurements that we set up. So the credits here are credits that you would need to actually conduct measurements. I'll set up a couple measurements later and show you how that works. Here is a list of my measurements. These are recent measurements that I've actually conducted. Here are the quotas that I have for how much that I can run on a particular day. Here's probes that I actually host and the state of those probes. And then we also have a card that shows you community events that are happening and system messages. And if you happen to be using the backend API, if you've created API keys for making direct calls to the backend APIs, you can also gather information that way. I should say that the entire UX and UI is one user interface that relies on all of the APIs. So you could actually conceivably build your own interface using all of the APIs to pull the same information and display it in a web page or in some other format somewhere else. So this is a kind of overview of the dashboard. Next, if we move on to probes, you actually can see these 16,000 probes that I talked about. You can see a list of all of those probes and you can search through them. You have a public tab, which shows you all of the public probes. Those are other people's hosted probes. Or if I clicked on mine, then I can see the probes that I have that I'm hosting. You can search for anything by, say, a probe ID and pull up a list of probes. This is another probe that I happen to host. You can get information about the probes. You can see and sort by country, a description, tags. You can sort by what their connected state is, because probes have to be connected to the network in order to function. And you can see what their last status was. This probe has been up and connected to the Atlas network for the last 6 days without interruption, and whether or not they're public, and whether or not you want to favorite them or hide them. I'm sorry, is there a question? No? Okay.
No, please, but
Oh, okay.
we want
Sorry.
you to increase your volume a bit.
Okay. Let me know if you, yeah, I can speak louder if you want, or let me know if you can hear me okay. So if we're looking at the probes page, let's say we want to go and look at the detail of this particular probe, you can click on the ID and that will take you to the probe detail page. And on the probe detail page, you can see details related to this probe. You can see where this probe is. You can see system tags that are related to its IPv4 or IPv6 capabilities, or other items that relate to the status of the probe. You can see what ASN it's in, and you could link out to RipeStat to get information about those ASNs. You can see the, oh, hold on just a second, I'm sorry. I just want to make sure before going on, can you hear me okay? Because Leah just told me that perhaps you're having some problems hearing me. I don't want to talk too much if no one can hear.
Hello, Stephen. Could you please increase the volume from your side? Hello, Stephen. Can you hear me? Hello, Stephen. Hello, Stephen. Yes. Could you increase the volume from your side?
Okay. Can you hear me now? Ooh. Hear me now? Can you hear me?
Yes. But increase the volume a bit.
My volume is now all the way up. Can you hear me?
Yes, it's better now.
Okay, great. Let's see. So should I start over, or did you hear the first part of my presentation?
You can go ahead and start now.
Want me to start over from the beginning?
Please.
Okay. So let's go back to the beginning here. And like I was saying, my name is Stefan Swess. I'm a front-end UX, UI, and visualization specialist for the Atlas project. Ripe Atlas is a network of roughly about 16,000 probes at the moment that are scattered throughout the world. And these probes are used to make measurements against various targets on the internet, which can help reveal information about the state of internet traffic, about whether there's bottlenecks or interruptions in traffic, or whether routing is working the way that network engineers think and hope that it is. So today I'm going to give you a brief tour of the Ripe Atlas interface and talk to you a bit about how the Ripe Atlas interface works. And maybe if we have time, I'll conduct a couple measurements and show you how that works and take some questions. So logging into Ripe Atlas, the first thing that you see is the welcome page. At the top of the welcome page, you see your name, you see what groups that you belong to. Normally you would see, let me pull this up to the top. Normally you would see at the very top your quick start guide for your particular user types. So once you log in, this gives you some quick guide and tips and information about how to use Atlas with a welcome aboard, a little bit about measurements, analyzing your network, and places that you can learn more about Ripe Atlas. And any of the cards on the dashboard can be dragged around to different places. You can also collapse them so you don't need to see them, or drag them completely out of the way so you don't need to see them. The dashboard is really set up to give you information that is personalized to you. So we see information about the credits that I have, my quotas that I can use for creating measurements, the previous measurements that I've made, and probes that I happen to host as I'm a probe host. It's important when using Atlas that if you can anyone without any credits can view other people's measurements, information about other people's probes. All of that is free to use, but if you want to actually perform your own measurements, then you need to have some credits. And in fact, Leah just pasted something in the chat giving a voucher so that anyone that has a Ripe Access account, which you can sign up for free, you can then use this code, this voucher that Leah has just included in the chat, which will allow you to have 500,000 credits, which you can use to test out measurements within Atlas. So moving down on the dashboard, like I said, we have my measurements, my probes. We have some tools like quick look measurement, which I'll go into detail in a little bit later. We also have API keys. So the interface that you see in front of you, all of the website and interface and app that we're using, these are all based upon APIs that are provided by the Atlas project. And we pull information from these APIs and configure this interface. But you could just as easily make your own API calls and create your own interfaces from the exact same data. Further down, we have community events, telling you about events that are upcoming, messages from the system, and other cards that are potentially related to you. Next up, we have the probes listing. As I was saying, there's something like 16,000 probes currently that are connected at any given time. And here you can see the full list of probes, and you can search through them you can order them by country. You can order them by ASN or by ID. You can sort them by their connected status, only show me connected probes as opposed to disconnected ones. You can look for a particular probe ID, and the list will filter live and show you that. You also have advanced searching, so you can look for IDs that are higher than or lower than a particular number. Or if you want to search by tags, these things that you see here in the middle, the description and tags, you can also search probes by the tags. If we go into this particular probe that I've pulled up, which is actually another probe that I host, you can see details about this probe. You can see information such as the tags on this particular probe. You can see what ASN it's a part of. And in this case, it's Odido here in the Netherlands. You can see the country, when it was connected, first and last. You can see traffic information. This is the traffic that is seen by the probe, the actual network traffic that is running through the probe over this particular time period. And you can look at this through multiple different time periods. You also have a link to measurements that are currently running on this probe or measurements that were recently stopped. As you can see right here, there are 564 measurements that are currently running on this probe. If I click through to that, it'll take us to the measurements page, and you can actually see these are the measurements that are actually running on this probe at this moment. Let's go back to the probe detail page. Other things you can see are network information from the probe. In this particular case, this probe is running IPv4. It doesn't support IPv6, or rather, it's not connected to an IPv6 network. And you can see the connection history of the probe, how it's connected to the network or disconnected, and for how much time the probe was connected or disconnected. We also have the results tab for a particular probe. And this one's really interesting because it will show you well-known measurements that are running on this probe. This is over the last 12 hours, but it could just as easily be the last week or the last month. We also have a number of built-in measurements that are running on this probe. And if you click on any particular, you see something in the data that makes you wonder, and you click on this particular point, you then have the opportunity to show trace routes on either side of that point, so you can really analyze the data. And once this data loads, you can then see this is the time frame. It's a one-day window, and you can actually see changes in your trace routes over time in this time period. You can see that in this particular case, in this diagnostic, we pulled 56 changes, or sorry, there were 56 changes detected in that time period from 96 trace routes. And you can see in these cases that there's changes to the hops, there are paths that are added or removed, and you have several pages of information. You might also see, like in some cases, the change might just be that there's been a large change in the RTT value for a particular hop, and that's something that you can see represented in this visualization as well. Finally, if you happen to be the owner, then you can actually manage this particular probe, and you can share it with other people. You can change the notification settings, or you could even transfer the ownership of a probe to another Atlas user. Moving down on the list, we get to anchors, and it's important to talk a little bit about the difference between anchors and probes. Probes are something that are anchors are kind of a fancier kind of probe, where that probes can be installed pretty much anywhere. We have hardware and software probes that you could install pretty much in any network. They could be behind a firewall. They could be in many different locations, and they can be used to target, to make measurements against targets across the internet. Anchors are much more beefed up versions of probes. They actually allow a lot more to happen. You can actually target anchors. The critical differences between the anchors and the probes is that the anchors can be targeted by measurements from many probes simultaneously, whereas the probes can't be targets themselves. And so that makes them kind of useful as a stable, well-connected reference points on the internet. Every anchor that's installed anywhere, and there are there are certain hardware and network configuration requirements to install an anchor that are much higher than installing a probe. But when these anchors are installed, every anchor continuously runs measurements against every other anchor, and this creates a mesh of reference points across the internet that allow you to really understand a lot more about the traffic in these areas. So it's quite important to have anchors installed in various regions around the world. And Leah could actually talk to you a little bit more about that and help you get set up with an anchor if that's something that you're interested in. I'm sorry. So in anchors, you can actually see that the anchors have host names, whereas the probes may or may not have probe names. If you click on a particular anchor, the detail page for the anchor contains extra information. It's mostly the probe information, but then we have these mesh measurements that I was talking about, where you can link through and you can actually see the mesh measurements that are running on running on an anchor against other anchors. Moving on, we have the measurements that I was talking about. And there are many measurements. You can see here that we've got millions of measurements that are running or that have been run in the past. And you can see, just like on the probes in the page, you can actually see my measurements versus public measurements. So public measurements are the ones that others are running on various probes or against various anchors and targets. And mine, these are the measurements that I've actually run in the past and that are showing here. So for instance, I ran this ping measurement, and if I click through, you can actually see the results of this ping measurement. You can see that 100 probes reached their target. The target here was to ping.ripe.net, which is part of our infrastructure. And the probes that were targeting ping.ripe.net, we took a random sample of 100 probes from around the world. And you can see that some of them that are further away took a lot longer to get there. And we can show just those, or just the ones based on the millisecond distance from the target, which is in Amsterdam. And you can see that the ones that were closer to here actually had a much better or much lower millisecond result. You can also see the results displayed in a table format, and then you can sort by min-RTT or by the time that the results came in, and you can see if there's any packet loss in any of these in particular, which there's not in this particular result. You can also then see the details of your particular measurements. This shows you how the measurement was set up, when it started and stopped, what the ownership is on this, what the tags are. So it's quite complete going into the measurement details that you can really see the results and analyze what happened with these particular measurements. Going back to the measurements page, you might be wondering how you would actually set up a measurement. Well, that's what this Create Measurement button is for. If you click on that and you have credits, you can then set up measurements. In fact, let's just set up a simple one that we'll come back to in a bit. Let's say we want to make a trace route measurement. Let's also make that to ping.ripe.net. And then here we can decide 50 random probes. Those are just chosen at random from around the world. But you could also just search for probes that you wanted to use. Let's say I only wanted to use probes in, this, let's say in just this part of the world. I could actually just grab those, get the 43 probes that are found in that area, and add them to my list. And you'll see those 43 probes are added to the selection. And I can decide whether this is a one-off probe or whether there's a start and end time, and it's something that is periodic that will repeat on an ongoing basis. But let's just say we make a one-off probe. It'll tell me what the cost is in credits for this one-off probe. We know that this probe is going to cost 2,580 credits, which is not very many. And if I'm happy with all of this, I could go ahead and say, create this measurement. and the measurement is created, and then you'll give you the link to the measurement, which will also show up in your mine column. But if we then click to this measurement, you can see that these are all gray at the moment. That's because the results are still coming in because they're trace routes. But we'll come back to this in a little bit, and we'll take a look at what the results were of this measurement. And actually, if we go back to our measurements and we go into mine, then you can see that the measurement that I just created right here, you can see the ID and the link. It's already showing in the My Measurements tab. We also have some internet maps that show you information about, for instance, connections from our probes to root name servers. And this is kind of interesting because every probe in the entire network is making connections to things like the KRoot servers, which we host at the RIPE NCC. And using this map, you can actually turn on or turn off values for the various regions and see, for example, who's connecting from where and which probes are connecting to which instances, and then turn on or off various parts of these to look at just the data from the servers that you're interested in. The other internet map we have is one that shows well-known RTT. This is a little bit related to the results graph that I showed you earlier. We're basically currently we're making measurements from all the probes to Google, Facebook, and Wikipedia, although we'll be adding others soon. And then you can see for any particular one of these, you can see what the distribution is and what the millisecond delay is. And so you can have a good sense regionally of how well or poorly connected the region's networks are to these particular well-known websites. Most of these are operating CDNs. So it could be that the CDN that they're operating is better or worse in a particular region, or it could be that they are not operating CDNs in those regions, or they have not enough resources in those areas for the millisecond time to be as low as it should be. We also have statistics about RIPE Atlas and the RIPE Atlas network. This one's kind of interesting. So if you go to the main statistics page, you can see, for instance, the coverage map. This shows all of the connected probes at the moment, but we could then also show the disconnected probes. These are probes that are have been connected recently, but are not connected currently. And so when you're scheduling a measurement, you might not want to schedule these particular probes. It's probably important to say that probes, by their very nature, and by the nature of the internet and internet connectivity, can be kind of stable or unstable. So it's quite normal for probes to connect and disconnect at various points over the course of several days due to a number of factors, internet connectivity, electricity, all kinds of things that can make probes connect or disconnect. So we don't actually consider a probe to be in what we call an abandoned state until it hasn't been connected for longer than, I think it's 3 or 6 months. So these are just the ones that are disconnected at the moment. These are the ones that are connected at the moment. And we can also see on this map on the coverage page, a country distribution layer, which if you roll over, you'll see how many probes there are in each country. So for instance, there's 1,185 probes in France. There's 2,400 in the US. There's 139 in South Africa. And so this map gives you a good idea of the concentration of probes around the world. The more countries that are lighter, where we have fewer probes, the more beneficial it would be to the Atlas network and to the community at large to have more probes in these areas, so that we can really get a good view on internet activity and what's happening on the internet, and how the networks that we're running are functioning as well as they can. Further down the page, we've got some information about the ASN, IP prefix, and country coverage. We also have pie charts that are showing the sort of the top ASNs, prefixes, and countries. So, for instance, if I'm hovering here, the US has the largest piece of the pie here with 2190. If we click to expand this, then it'll show you, it'll reload the map with just the country that you've clicked on. Let's see what else. Yeah, and if you click on the other, then you'll get just the top 10 categories spread out, so they're a little more easily read. The other piece of the pie is after the 10th category, what number of probes fall into other categories. We also have the status of the system at the moment. You can see how many hardware, software, anchors, measurements are running, etc. I should also mention, I don't think I made it clear before, that there's both hardware and software probes. So in the past, we were always connecting a little hardware device to a network, and those were the hardware probes. But in the past several years, we also have available software probes, and those are ones that anyone can install into their network. You can download the software yourself from the RIPE Atlas website and install the software probes in just a few minutes, and then you can actually be running a software probe pretty much from anywhere. You don't actually have to have a piece of hardware that's connected to your network. And they work just like the hardware probes for the most part. They're making measurements. You can schedule measurements against them in the same way that you can the hardware probes. And that software is all open source and all available up on GitHub. Other things we show contributors. These probes have the highest number of results within a particular month, and trend lines over time. So users and probes over time, you can see how they're steadily growing, and the anchors over time as well. You can see how those are also growing, which is nice. Moving down into a new section that we have been developing, we have use cases for Atlas. It's been our goal recently to try to make Atlas use cases more obvious and more usable, so people really have a clear visual sense of what's happening within Atlas. I'm going to show you a couple of the other use cases right now. Like one of them, actually, it's a new statistics thing that we'll be releasing next week. This is on our beta site, which is why it's not yet on the production site, but it'll be there next week. Is we have a view of all of the Atlas resources that are within various LIR members in our service region. So if I make this full screen, you can see like France Telecom, you can see DE.Telecom. This allows you to zoom in and zoom out and see the resources that a particular LIR have and what they have within them. So if I click into this, it zooms into that particular LIR, and then I can see within the prefixes that this LIR is running, oh, well, we see we've got this number of measurements and this number of probes. And if we click through any of these measurements or probes, then you can actually get to the detail page for those particular probes or measurements. So it's kind of a nice visualization that lets you see what the utilization is of Atlas resources throughout the network. You can also filter this. So I could say, just show me stuff that's in the Netherlands, for example. Don't show me measurements, only show me probes and anchors. Don't show me empty LIRs, just show me ones that have resources in them. And in this way, you can really zoom in and out and get a good sense of what the utilization is of Atlas resources within the larger community. Another nice use case, I think I was telling you before about the reachability testing, or about the quick look. We have the quick look on the dashboard, but we also have a full use case for quick look. Here, for example, if let's do ping.ripe.net, and we'll do a ping measurement, and we'll do it worldwide. If I then go ahead and create this measurement, it will actually make a request to create the measurement, and then it will live stream the results as they come in and show you a live view of what's happening with 100 random probes on the internet. So this is kind of handy because then you can really see you can really see the results right in front of you. We also have a path analysis use case, which is using our new Kipu tool, which I will also go into in a minute. But it's another visualization of the same kind of data. And I'll actually let me pull up a trace route, which is the main use case for Kipu. Let's see, I think I've got one right here. Yeah, here's an example of a measurement, a trace route measurement that I made, similar to the one that we made before. But this trace route measurement then can be visualized using this new visualization called Kipu. And what's nice about this is that you can then, let's make this full screen, you can actually zoom in and zoom out, and you can see if you hover over any of the source nodes, each one of these represents a probe. It represents a particular probe trace route within that measurement. You can see that we show the entire trace route from this particular probe. This one happens to be in the United States, to the destination, which is in the Netherlands, in the RIPE NCC infrastructure. But you can see at a glance all of the trace route information for any of these source probes and the path that they took. If you zoom in a little closer and you click on, let's say, a node that is coming together like this, this is just showing where these the merge points for these trace routes as they head off to their destination. So any particular one of these, you could then highlight and see the trace route for those particular views. We have multiple ways of filtering this information. So, for example, we can see it instead of in the radial layout, you could see it in a horizontal layout. You can show or hide the labels on this, and then you could zoom in and see the labels on any particular point, and you can see information about points throughout the trace route visualization. You can also filter it by, let's say I only want to see the ones that ran through an IXP. I can just type IXP, and it will reduce, it will live filter the data that you see in front of you. You also could filter by countries or by continents. So, for instance, let's say I didn't want to see the ones in Europe and I didn't want to see the ones in North America. Then I could just see what's left within this particular trace route. And you can really dig into the trace route information and get good information about, especially for network operators and network engineers, how the routing is working, how the trace routes are working, whether there's particular bottlenecks. You could also, for example, you could view in ASN mode, and then you'll see the paths that these take from ASN to ASN. And that's really useful for network operators that are, that are doing their BGP planning and others to make sure that things are passing through the networks that they expect. And that's pretty much Kipu. Let me go back to where we were. Other use cases. Another interesting one that we've developed recently is probe connectivity. This allows you to visualize connectivity using the connectivity state of the various probes, any of the 16,000 around the world. To give you an example of this, let's see, I thought I saved one up here. Yeah, here's a good example. So in this particular case, between this particular start time and end time, we happen to know that there was a huge power outage in Chile. So I choose the country, I choose the dates, and I load the probes, and you can see really clearly this drop right here that shows when that power outage occurred. And then you can actually go into the data and you can sort it by various means. Like I could sort it by uptime. And then it's really clear actually where the break was. You can actually see the connected or disconnected state of any of these particular probes. These are all the probes that it's using. But it's really a nice tool either for looking at your own probes, and you could do that with a location and radius, or looking in a particular country or a particular ASN, or by a list of probe IDs that you're interested in to see what the connectivity state was with those. So if there's a power outage or if a particular company got knocked out or something like that, you could really tell from if there are probes in those networks, sort of get another view on the network and what's happening. Let's see. I think I've gone through most. Let's, I guess, go back and take a quick look at the measurement that we made, which was this ping measurement. You can see now that it has results, and these results are all similar to what I showed you before, that they're showing by the particular amount of time, the RTT, the milliseconds that it took to get to the target from these various places around the world. We can also look at, let's look at a trace route maybe. So yeah, if we look at this particular trace route, then you can see by RTT, or you could also see by destination IP. In this case, there's only one, but when you're making a trace route measurement, each probe is resolving. If the target is a domain, each probe is resolving that. So potentially you could have multiple destination IPs that are resolved differently. In fact, I think I have a good example to show you of that. Let me just pull this up real quick. Let's see. Yeah, let's look at, I think this is maybe a good one. Yeah, so as an example, here's one that's going to store.apple.com. So it hits a CDN. So because of that, and each probe is resolving store.apple.com on its own resolver, you can see that there are, because it's running on a CDN, there are many different IP addresses that represent that. So in Kipu, we're actually showing multiple targets for these. And if we go to the detail measurement part of this, you should be able to see, yeah, if we click destination IP here, you can see these are all of the destination IPs that were resolved from this particular query. There were 138 probes that reached their target, and each one of them had a different resolution. So like 19 of them resolved to this IP, 7 of them resolved to this IP. And in this way, you really get information about the difference between the time it took to get to their endpoint or the resolution. And you can also pull up the individual trace routes if you want, either in Kipu or here within the results, the detail results. I apologize that I am going to have to leave in about 10 minutes, but I wanted to leave a little bit of space for some questions. I'm sorry with the technical difficulties that I ran through this so quickly. But I did want to leave a little bit of time available for questions if anyone has any, and also to say that Leah will be sticking around and will be available also to answer questions about the probe network and about anchors and about RIPE Atlas in general. So were there any particular questions or that anyone had?
Yeah, thank you so much, Stephen. Yeah, so now the floor is open for more questions, even though we wish you would have stayed longer.
Hi, Stephen. This is Isaac. So considering that RIPE NCC has a different area of jurisdiction, do you give probes to African countries? We in Ghana, can we get the probes to install? And what protocols or technology do you use for your measurements? Do you use pings, flows, SNMP? Which flow, which technology do you use to gather your metrics?
What the technology is behind the scenes, but I can tell you that these are the types of measurements that you can perform against a probe, or actually from a probe, or targeting anchors. So you can make ping measurements, trace route measurements, DNS measurements, TLS measurements. HTTP measurements can only be made against anchor targets, the anchors that I mentioned before, and NTP measurements can also be made against any target. And these are the main ones that you can configure. The probes are available to anyone around the world and can be installed in any network, both the hardware probes, and I believe Yazid is coming a little bit later, and we'll have some probes, and also that the software probes, which are freely downloadable and installable, can also be installed anywhere. So we very much encourage these probes to be installed globally around the world. It is true that there are some networks which already have many probes in them, and so we're not really encouraging probes to be installed in those networks because we already have great coverage in those particular ASNs and networks. And Leah has a lot of information about those in particular, but I know in a lot of countries in the region near Ghana, it would be quite beneficial to add more probes to the network, both for people locally to have a better view of regional networks, but also to participate in this global network of probes that can target other endpoints and understand more globally what the situation is in terms of internet traffic. Did that answer your question?
Yeah, it did. So one follow-up question. You mentioned measuring DNS response times. Which DNS do you query in this situation?
A DNS measurement, actually, you can choose to resolve on the probe, or you can let Atlas, if you don't choose resolve on probe, then you can actually have Atlas pick the server that it's going to use. I think it maybe would be instructive if I show you one of the, let's see. Yeah, here's a good example. So here's a DNS measurement that we made against Amazon.com. And we had these measurements resolve on the probes themselves. And so you can actually see where these resolve to. So like these three probes resolve to Anycast address 8.8.8. The vast majority of them resolve to a private, which means probably that they were on their own network and their own router, home router, did the resolution and then forwarded it on. So the vast majority of these probes were resolved in private networks and private routers, but some of them were resolved to 8.8.8.8, some to 1.1.1, etc. And by making these measurements and then viewing them in Kipu, you get a kind of clear sense of the diversity of DNS resolution. And in some cases, when you click on these, you can see that they resolve to more than one place. So you actually have the first resolver, 1.1.1.1, but then the second one, which resolved to 1.0.0.1. Both of those are Cloudflare, but if you expand those, then you can actually see the results that came back decoded for any of those DNS measurements. So it can be quite handy to troubleshoot DNS problems this way.
So
The
the last question is, how do we get create an account to get access to the RIPE Atlas?
Super easy. Basically, let me log out here. And if you want to create an account, you can just click on that profile image, empty profile image. And if you don't have an account, you can actually just say new user, sign up. These accounts are free. You can sign up for an access account. And then once you've signed up for that account, Leah actually placed a voucher in the chat here, which I hope will be shared with the group there, that will allow you to get 500,000 free credits. So you could play around with Atlas. You can make a lot of measurements with 500,000 credits. So you first sign up for an access account, and then you can actually apply this voucher. And let me actually show you where that is applied. Go back to, let me log in here. Hopefully, there we go. So once you have logged in, you can then you can go to the dashboard, you can go into manage credits, and then you can redeem voucher right here in the manage credits area. You just put in the voucher code here, you click redeem, and it will automatically add those credits to your account. And then you can just start using them to create measurements or do what you want. Again, to be clear, just viewing already existing public measurements is completely free. You don't even need an account. You don't need to log in. So you can already go to Atlas, and without even logging in, you can see probes and measurements and the results of those measurements, and you can look at a lot of the information that's already in Atlas without having to, without needing any credits at all.
Thank you, Stephen. I have one question.
Sure.
So, first of all, thank you for the presentation. I think it was very enlightening.
Well, thank you.
Do you have a visualization of comparing past trace results with the current trace to see whether there are changes in the trace path for you to troubleshoot?
Absolutely, absolutely. As an in fact, I'll show you an example that I was talking about before, which was let's see. So there's in the probe detail pages in the results tab, we have a new traceroute comparison component that we're using here, but we're also starting to roll it out in other places. Currently, it's available here, which means if you click on any particular point and show the trace routes from that, it will load trace routes over a day period, and it will show you any changes. It will show you hops added or removed. It'll show you RTT changes, or it'll show you ASN or IXP changes. And within these time windows, you can actually see, it will tell you how many changes it detected. It will tell you how many trace routes it actually loaded over that time period. And then by clicking on these, it will load beneath the various changes in trace routes. I'm trying to think if I have one that is maybe a little more, that's showing a little more changes. Let's see, I think I have one. So here's an example of the standalone component, which isn't yet released, but it will be soon. Here's a perfect example. So you can actually see that in this time frame is centered on April 4th. There were 23 changes detected, and that's out of 200 trace routes that were found in this time window. And so in this particular one that's highlighted, you can see that there are ASN changes between these two trace routes, and you can see what the later trace route and what the earlier trace route timestamps are. And if you click through these, it will keep loading each change that's detected and allow you to look at the two trace routes on either side of that. And then you can also copy the trace route to clipboard and then paste it somewhere else for whatever you need. But it will show you however many pages of changes there are within this activity, and it will reload those trace routes on either side so that you can examine the changes between them.
Thank you.
You're very welcome. Is there any other questions? I need to leave in about a minute. And again, I really apologize for that.
All right. Okay. So, Stephen, thank you so much for the demo. I think you have thrown more light on what we need to know, and we are very grateful. Thank you so much.
Thank you very much for the invitation.
We are going to quickly move into the next phase of the program, which is the panel discussion. Yes.
Bye.
And as you can see, we are very ready. Our panelists are ready. The moderator is also very, very ready. So without much ado, I would invite our guest panelists to have their seats comfortably. All right, so first on the list is Mr. Isaac Sachi. He is a network performance and QoS engineer at MTN Ghana. So with a round of applause, let's invite Mr. Isaac Sachi. The next is our very own Mr. Emmanuel Togo from Garnet, who is also the network measurement and research specialist. Let's give it to them as they make their way to have their seats. Then we have, of course, it should be very balanced. We also have Miss Vivian Afua from Media Foundation for West Africa. Miss Vivian, please kindly make yourself very comfortable. Then we also have from the NCA, Mr. Fazel Ata Opoku, Quality of Service and Regulatory Officer, to also join them. And finally, our moderator of this session is our own president, Miss Maud Elliott Ashong. Ashong Elliott, yes. She's very particular about the arrangement of her name, you know. All right. So, ladies and gentlemen, both here and online, we have our panelists ready, moderator ready to have a very wonderful conversation. Thank you, and I hand over to Miss Maud.
Thank you very much. And good afternoon, everyone. I pray we have a very insightful and informative session. The reason being that all morning we've been listening to our speakers from Cameroon, from Cote d'Ivoire, from Benin. So the idea is exactly how internet measurement and the tools and methodologies they have been using across the world in a way. But now we want to have a discussion about Ghana. Okay, so why are we having this event? It stemmed from July, when we know this year is the internet is 30 years. When internet came to Ghana, this year is 30 years. And we had some form of celebration as ISOC Ghana. And we were wondering, at one of our sessions, we had a short presentation on internet measurement. And I said, no, I don't think this was enough. Because personally, maybe because I'm an academic, I didn't know much. And I got interested. So that is where the discussion started from. Okay, so who are those who are into internet measurement? So at the end of the day, we found out that, ISOC Global was involved, ICANN was involved, AFRINIC was involved. Oh, okay, so it means it's a bigger thing than I knew about. But what's happening in Ghana? So that's how come this whole conversation and us having this event today. So we are going to talk about Ghana. And for our audience, the panelists are coming from, so we have a rep from the regulator, we have a rep from the academic community, a rep from the telcos, and that's MTN representing the telcos. And then we have, yes, so far. And then the CSOs, yes. ISOC, we are CSOs, but one of our major partners in fighting or discussing the advancement of internet here in Ghana, discussing gender issues, discussing digital rights, it's Media Foundation for West Africa, and they are also here with us. Please give them all a round of applause. Okay, so we're going to talk about the Ghanaian study. So I'm going to start with, it could be anyone. Who wants to go first? Okay, let me start with MTN. Okay. I have a few questions for you. What tools and metrics does MTN rely on to detect congestion, latency spikes, and service degradation?
Okay, thank you very much. So from the perspective of a service provider, telecom service provider, we have we leverage two kinds of tools. we have the proprietary tools that most of the OEMs or the vendors provide for insight. And then we also use the ones that are publicly available, the open source tools or the other tools which are in the market for governance. So if you ask me, we have proprietary tools from vendors that we use, but of course we have also open source tools. We have other commercial tools as well that we can use to check some of these things. And so it depends on what you want to, what metric you are interested in monitoring. You get it? So if you want to measure latency, we have tools that you can use to check latency. If you want to measure jitter, you have tools you can use to measure jitter. And so that is...
So assuming you want to measure latency,
yeah.
Tell us, how do you go about it?
So because we have an extensive network, let me use the open source tools that we can leverage on, or the publicly available ones. For instance, SmokePing. SmokePing sends ping packets every 5 minutes to remote destinations and grabs the results. So if I have sites deployed in Tamale, I have sites deployed in Volta region, Greater Accra. From a central location, my probe sends these ping tools and then it grabs the results. So in that way, I'm able to see if there are packet loss along the path, because it uses different grading or coloring to let me know if I'm experiencing packet drops or the link is fine and all of that. So I'm able to use that particular tool to monitor my latency. And that gives me a fair idea of how fast packets can travel within the network. And if there are congestion issues, I mean, we have some other tools that do monitor utilization on links through SNMP. So those ones too would be able to tell me if I am 50%, I'm using my link at 50%, 70%, 100%, and that informs me. It gives me insight, which I'm able to use to forecast and then plan my network or redistribute traffic to prevent any downtimes.
Okay, thank you very much. If I would want to ask Mr. Atapuku a question. So what are the KPIs and methodologies? What KPIs and methodologies does the NCA use to assess national network quality?
Okay, thank you for the question. Yes, so so the KPIs that the NCA uses. So before I go into the KPIs, I'd just like to give a little background as to the quality of service measurement that the NCA.
That's okay.
Yes. So basically, the NCA Act was enacted in 2008. That's the current act. Before that, there was an act in 1996. So the new act, 2008, in that act, the NCA was mandated to do quality of service measurements. So this is basically measuring quality of all service providers, voice service, data service, and all that. So that's basically internet service also. So in the previous act, it was not too clear. It wasn't clearly stated there that the NCA is supposed to measure quality of service. But in the new act, NCA was mandated. So that was 2008. And in 2009, the NCA procured its first equipment for measuring quality of service. So that was a drive test tool, which is a tool that is installed in the vehicle, and the NCA drives around. And in that vehicle, there are test handsets. So those handsets mimic how a typical user would experience the network. So that the phone would, let's say, do a voice call, and the certain KPIs will be measured on the call. The phone will do a data test, to do an FTP test, to do a ping test, another data test. So that is the history behind how the NCA has begun to do quality of service measurements. So some of the KPIs that we measure. So there are a lot of KPIs, but I'll just stick to some of the data ones, the ones that are of interest to us when it comes to the internet. So we assess the mobile network operators on data throughput. That's a very typical KPI when it comes to the internet. So that measures the speed with which data is transferred across networks. So data throughput, NCA would measure that. We would use our drive test tool that we procured in 2009, but also we used that tool from 2009. In 2016, the NCA replaced that tool with a different tool that also does quality of service measurement. It's also a drive test tool. And also in 2016, the NCA also procured a tool called the Network Monitoring System. It complements the work of the drive test tool. So what the NMS Network Monitoring System does is it's a server which has connectivity to the OSS of all the telcos in Ghana. And the telcos send us performance measurement PM files. And those PM files are used by the NCA to compute KPIs. So the NCA uses the NMS and also the drive test to complementary to measure the performance of network operators. So back to the KPI. So as I mentioned, we would check their data throughput, downlink, uplink for the various technologies. So for 3G, we'll check, we'll have a target. And also 4G, we'll check, we also have a target, a different target. Because of the difference in the technologies, what they can do, we set different targets for them. So for example, for 3G, we would set, let's say, an average throughput, that they should meet an average throughput of, let's say, 1 megabits per second. And for 4G, those should meet an average downlink throughput of, let's say, 5 megabits per second. And uplink of, for 4G of, let's say, 2.5 megabits per second. For other services, there are different KPIs, targets that we set for them. So this is for data throughput. We could also check for latency. So latency on a 3G network, for example, we do a ping test with our drive test tool. And the target for the ping latency currently for the 4G is 80 milliseconds, an average ping of 80 milliseconds for the latency. So other KPIs are data service access time, which measures how long it takes when you enter a URL in a web browser and hit enter, how long it takes for the page to begin to load. So we do what that's a data service access time. We do it to google.com, and within 5 seconds, the page should begin to load. So these are some of the KPIs and the targets that we give to the network operators.
Thank you very much. Since the mic is there, Auntie Vivian, from the CSO's point of view, how should internet measurement data be used to support transparency, public accountability, and equitable access to information?
Okay, thank you very much, Maud. I'm very happy to be here. Most of the time, civil society has to fight for like a seat at some of these conversations because mostly you find that the technical community is the one engaging in some of these processes. So I'm very happy to be here. From the point of a civil society perspective, I think that for the data to be very useful, it's important that it's accurate and easily accessible. If it's not easily accessible, it makes it difficult for the end users or beneficiaries to actually see the importance of the exercise. It's also important that there's like regular updates and feedback mechanism where people can show whether they have an issue with it or they feel that there's an additional information that is relevant in the context that can be useful for the measurement exercise. And it's also important that the data is packaged in a way that it's easily accessible by everyone. So we've talked about open data standards. So ensuring that it's open data so that people can easily access. It should also be in a way that is like visually appealing and contextualized. Sometimes the information is so technical that people are not able to make quote unquote sense out of it. And then there are also nuances in terms of like geographical context and all of that. There's some measurement tools or breakdown of the information that if you are in Ghana or a remote area, you look at it and you don't really get what the information is trying to communicate. So, putting it in a particular context, taking into account where we are and our circumstances, it really helps to bring home the point of what we are trying to communicate. It's also important that various channels are used to share the information. So government websites, social media of civil society organizations should be able to access this data. The technical community, the private sector, the telcos, the regulators, and all of that. So every stakeholder should be able to access the information, and the information should be packaged in a way that is beneficial to the stakeholder that is accessing the information. If it's students, they should be able to understand the data that is presented. They should be able to have like visuals or graphics that breaks down the technical aspects of the reports that helps them to understand and appreciate the information that is being presented. I think that's what I can say for now. Thank you.
Thank you very much. Thank you very much. It's something I've also observed. I think maybe I'm in between the technical and the non-technical. The technical community has a lot to say, but we are not able to communicate it to the end user. So just to all of us, I know most of us here are technical. We know we do a lot of things, but we don't communicate it. So visualize it, bring it down to the barest minimum for everyone to understand. And when we understand, we would help you and even support in the adoption of most of the things that comes up. To the academic community, I'm coming to you, Mr. Togo. Okay. What Ghana-specific patterns or anomalies have you observed in routing, DNS, latency, and measurement data?
Okay, so thank you very much. Coming from GANET, the Ghanaian Academic and Research Network, we deal with universities, colleges of education, technical universities, research institutions, hospitals, and those that are accredited by GTEC to work in the tertiary space. So because we try to interconnect them so that we'll create a platform for sharing of resources or to facilitate collaboration among member communities. So from where I sit, what we see firstly is about the campus networks itself. The networks at the various institutions, most of them have some challenges. So what happens is that when they have issue, they feel that the issue is coming from the service provider. So their first point of call is to reach out to the service provider that, that something is wrong. But what we've realized is that most of the issue was coming from the internal network because of how the network was designed. So it's not able to utilize the capacity that is coming to them. So that, first of all, is a big challenge. And then secondly, this morning we've heard from the earlier presentation, our routing hygiene is not so good out there. If you look at the Pulse publication by Internet Society, we are scoring about 39%. That is very low, which means that we are prone to route leaking. So because we are not protecting our route objects, people can hijack our route objects and then use it to do malicious things. And that doesn't give us good picture out there. And then our networks will not be healthy in the long run. And then we also see a lot of asymmetric routing where we have outbound traffic going on one leg and then the inbound traffic going over another link. So sometimes it's a good thing, but if it's not properly implemented, it can be a problem because of announcing prefaces wrongly, because if you don't announce your prefaces very well, there will be inconsistency in preface advertisement, and that creates a lot of problem, and most often creates problems for troubleshooting, because your traffic leaves your network in one direction, and then when it's coming back in the other direction, and you don't know where the problem is. It may be that the traffic is coming through a congested link, and therefore there's some slowness in that. So we see a lot of that in the network, because people try to have what you call dual homing in a way to build redundancy. In that redundancy, some people tend not to do it so well, therefore it creates a problem in the network. Then the other interesting bit was that most of the institutions have their DNS resolvers outside the country. So, and then getting to these resolvers takes a long time to resolve address, and then that makes the internet experience very poor.
How can we resolve that?
Yeah, so to resolve that, we need to have local DNS resolvers, because you see a lot of people using cloud infrastructure, so they host their DNS on Cloudflare and the rest. So if for instance, if I'm in Ghana, I want to access a site in Ghana, and that site has the resolver outside, I have to go there to resolve before I start browsing. And if the latency is very high, as Isaac and Co mentioned, if the latency is very high, then that slows down my experience on the internet. And then also it has impact on our dependency on external connectivity. So last year, for instance, I think last year in March, when we had internet blackout, we couldn't access any service because most of the these critical infrastructure are not in country; they are hosted outside. So that creates a lot of problem. And also you see that when the traffic is going out, it takes, even though two of us we are or have two institutions in the country, I want to, for instance, I'm on Telecel network, or I'm on University of Cape Coast network. I want to reach UMAT network because of how some configure their network due to multi-homing, which some of them do not do very well. You see that I have to leave the country and come back. So we take a lot of detours, go out of the country, use expensive links to access a neighbor connectivity. So that creates a lot of problem, even though some of these providers are connected locally using our local internet exchange, but we do not utilize it properly because some of the service providers tend to force users to use their paid link. They don't want them to use the exchange. So we underutilize the exchange that we have in the country. That makes the cost of internet so expensive. So that's what we've seen so far in the ecosystem, that we have poor DNS resolution in our country. We have routing issues. We are not protecting our route objects, and therefore creates security issues within the country. And then also, most of the institutions don't have monitoring tools. We just saw that our part of the world is so dark, whilst the other places are light up. We don't have a lot of monitoring tools. So we find out that if an institution is having issue, it's not able to tell where the issue is coming from. The first point of call is to call the service provider because it doesn't have the capacity to be able to monitor what is happening internally before calling for external support. So these are the things that we see in our space. in recent times.
Thank you, Mr. Togo. Then it means we have a lot of things to handle. So the telcos, MTN, what are you doing to support this?
Well, he mentioned a few things which I would like to also highlight on. The first he mentioned was DNS resolutions going out of country. It is more of a problem with people who, for want of better word, maybe for convenience or for lack of understanding, think that the DNS infrastructure is what you already know outside there. It is something which can be built locally, and you can leverage the skills of people in the industry to have those ones built. Now, the good part is once you're able to build your own resolvers, like Tego mentioned, you save so much you cut down on latency, that the resolution time becomes quicker, and then you are not under the influence of an external resolver. So in the cases that he mentioned, if you have any service provider, any DNS service provider going down, it doesn't take you totally out, because on your side, you are resolving directly against the root servers, then going to the authoritative name server. So it gives you a way out, and you are not so much tied down to what the DNS service providers do. So I think that we should understand clearly the purpose of or what we need, and then fashion a DNS solution in-house that will solve the problem that he just mentioned. Because some people have local DNS, but then they are doing forwarding. So he's forwarding literally all his traffic, he's aggregating on a resolver, but pushing it all out. And it's sad to see, because ICANN has a map that outlines all these statistics. So they look at the country, they look at the organizations, and then they can tell which of the organizations has resolution on DNS with the same AS. That means that you have a local DNS within your infrastructure, or whether you are using any of the publicly known DNS facilities. And sometimes you see institutions which you think should have deployed in-house solutions using publicly available ones. Sometimes they have the local ones, but like I mentioned, they are also forwarding the traffic outside. And so that becomes a challenge. Then on the second point of internet exchanges and all of us using it, now we need to understand that the internet exchange itself, there has to be content there for us to benefit from the infrastructure we've set up. So if we have an internet exchange place, we go there and then we all exchange routes. Now, someone mentioned somewhere that there are some players in those internet exchanges that have selective peering policies. So to give the intention to make it, to misconstrue it as the big player there thinks he's big, and so he will not peer with the small guy because he is selective. But if you look at the internet exchange places themselves, their policy is selective, because what it means simply is for you to be admitted into the exchange, you must have done your due diligence, like Tego said. You must have cleaned up your routing, so that if somebody connects you, you not create a loop, or you not tunnel through somebody's network, or you just not dump unnecessary things in that person's network. So for you to pass that thing, there are check marks, checklists that you need to fulfill. So that in itself is selective. Now, let's go past the policy. We are all at the hub. Let's ask ourselves, how many cloud infrastructures do we have here? How many CDNs do we have here? How many local contents do we have here? If the numbers are small, then you realize that we may have the exchange, but our contents are all not sitting behind the exchange. Because if a user is on MTN and needs to access a website or an app from a banking institution, which is hosted somewhere in the cloud, even though we have an exchange, the traffic will not go to the exchange, but it will go to the cloud, and it will use my internet upstream link. And so the local cashier will not serve its purpose. It is high time we agree as a country that we need to drive local content within these jurisdictions, because if we have several content sitting in the internet exchange, then that is when traffic will go there, because traffic would not go there for nothing. People should start hosting services locally, then we can benefit from having internet exchanges here. And then one thing to the operators of the internet exchange, sometimes they have a reactive response to happenings in the world. Today, if you have an internet exchange that started with maybe 1 gig connections on their router interfaces, people are doing multiple 100 gigs now, 400 gigs, 1 tera and all of that. So if your infrastructure as the middleman in the gigs or in the AIS is still 100 Mbps or 1 gig, 10 gig, then of course somebody who wants to bring content there will experience bottlenecks. So he will not bring the content there. So whilst we talk about pushing content there locally, whilst we encourage people to clean up their routes there, we also need to encourage the providers, the internet exchange infrastructure owners, to invest in infrastructure that is forward-looking. In that way, we would be able to utilize content locally, and then naturally traffic will grow in that area.
Thank you very much. Our regulator, is there a way you can? I'll use the word encourage. You should force. Is there a way you can force everyone to do the right thing?
Yes. So the regulator has done a lot in that space, and we are still continuing to do more. So, for example, Togo mentioned the incident that happened last year in March, when we had a major submarine cable cut. That is something that is very rare. No regulator could have anticipated that something like that would happen, but it happened. So prior to that incident happening in 2020, the NCA gave a directive to all the telecom operators in Ghana to have direct physical connections to at least 3 submarine cables for resilience and for redundancy. And we anticipated that there might be a case where some of the submarine cables may be cut. So that directive was given to them in 2020. The good thing that did was that last year in March, when 4 major cables were cut, we didn't have total blackout. At least there were some service providers that were up when there was an outage. So we had a major outage. 4 major submarine cables that come to Ghana were down. So we had, if you know some of the cable companies, so we had ACE down, we had SAT3, we had Main 1, and WAX down. And it was a serious disruption to internet in Ghana. And the NCA, when the issue happened, the NCA worked closely with the submarine cable providers to resolve the issue as quickly as possible. So when the issue was resolved, the NCA issued further directives to ensure that if any such thing happens again in the future, we will be safe and we will not have total blackout. So after the issue was resolved, some of the directives the NCA gave us that all submarine cable providers need to have a backup. So you need to have a backup on another submarine cable that's coming into Ghana. So in case there's a fault on your cable, or you are doing maintenance work, or your cable is damaged, you can route traffic onto another cable. So that was a directive to the cable operators. And there's also another directive issued to the telcos themselves. So the telcos were required to continue having physical connection to at least 3 of the of the submarine cables that are landing in Ghana, and also beyond that, they need to have a connection on a cable that does not land in Ghana but lands in another submarine cable in the sub-region. So that would ensure that if all the cables coming to Ghana are cut, we don't lose total internet in the country. We continue to have service. So those are some of the policies that the NCA has put in place to ensure that we have resilience when it comes to internet connectivity. Thank you.
Thank you. Another interest, something I'm interested in, how do you handle enforcement? So if people do not go by what you have asked them to do, are there punitive measures? What is there? We want to know.
Okay, thank you. So actually, there are punitive measures. So all these I've mentioned, there are directives that the NCA issues to these service providers, these telcos, and also the submarine cable providers. They are supposed to provide us their plans, their redundancy plans, backup plans, and all that. And when they provide it, the NCA vets them and ensures that they go by them. And if you don't go by them, you can be sanctioned for not doing that. So there are punitive measures applied when you don't obey these directives. Thank you.
Thank you very much. As for today, I'm on the regulator. Okay, I have another question. So, what regulatory reforms and data sharing frameworks could strengthen Ghana's measurement ecosystem? We are back to measurements. I think we deviated a bit. But are there other regulatory frameworks that are strengthening Ghana's measurement ecosystem?
Oh, okay, thank you. Yes, so Ghana is a member of the ITU, and the NCA being a regulator in the telco space, NCA plays a very active role in the work of the ITU. ITU regulates the telecom space. So currently, our acting director general, he's been elected onto the radio regulations board of the ITU, which is the highest decision-making body when it comes to spectrum assignment and all that. So it should represent the whole of Africa on that board. So the NCA works closely with the ITU. The ITU comes out with recommendations for the whole telecom space. So a lot of the work that the NCA does when it comes to measurements is based on recommendations from the ITU. So the ITU works through sectors. One of the sectors is the telecom standardization sector, ITUT. And there's one important study group under that standardization group, which is study group 12, which handles quality of service measurements. The NCA has played a very active role in that study group. Some staff of NCA have chaired that study group in the past. The NCA still continues to work closely with that study group. And a lot of the KPIs that we measure and the targets that we set are based on recommendations that that come out from the work of these study groups. So, for example, when we were determining the KPIs and targets for our 3G licenses and also our 4G licenses, we relied on a regulation like the ITUT E.807, which defines what the KPIs are and their targets. They give recommendation what the targets are. So the NCA relied on these recommendations when we were setting our targets for some of these, our 3G license and also our 4G license. So those are some of the ways that the NCA is working with international bodies to ensure that the KPIs that we use are relevant and will help ensure that we have good internet connectivity. Thank you.
Thank you. To our civil society rep, to Vivian, have you observed correlations between network performance and limitation in information flow or democratic participation? And how can measurement evidence strengthen advocacy? Sorry, I know it's a mouthful. Yes.
Okay, so I'll take the first bit and then I'll come to the second bit. Yes, so definitely there's a correlation between network performance and limitations in information flow when it comes to democratic participation. We know that in Ghana there's a rural-urban difference when it comes to internet use and even accessibility. when we talk about meaningful connectivity, that's gadgets that people use, the type of internet, how often they're able to go on the internet. For example, somebody is able to afford 1 Ghana data, but how often in the week are they able to make that purchase, and which websites does that 1 Ghana data afford them to be on? So there's definitely correlation between accessibility of the internet, information flow, and also democratic participation. If you don't have access to the internet, there are so many government ministries and even private sector network operators that put information online. And if you don't have access to the internet, you end up missing out on some of this information. There are people that need to take classes online. It affects how they enjoy their educational rights online and all of that. So there's definitely a correlation. It's important that we look at public awareness, creating public awareness, improving digital literacy, because there are so many people that have access to the internet but do not even know how to use the internet, do not know how to participate in spaces that are meant to promote democratic governance or democratic participation. At the Media Foundation, we have a local governance project, for example, where some of the assemblies created Facebook pages for their constituents or people that live within these vicinities, for them to reach the assemblies directly. And for a lot of them, even though they had Facebook pages, they did not even know how to search and access the pages of these assemblies. So you've created that platform, all right, but there's no way to access the information that the assembly is providing. There's also regional disparities. Like I said, Greater Accra internet is different from Kumasi, depending on the population and the demographic generally. There are disparities, and this affects access or participation in democratic processes. Again, network performance. There are places where you go and even accessing a normal network to make a phone call becomes a challenge. People have to stand at a particular place or climb a tree to send a text message and all of that. These things are real. I've gone to some places in Upper East where there's no network. Like, I went with MTN, it didn't work. The next time I ported to Vodafone and I went, and we still had issues. This is a few years ago. I'm hoping that by now it's been fixed. So for people who live in these areas, how do they, for example, if there's a state address by the president and they don't have a TV set to watch the president, they cannot join online if they have a mobile phone. There's no network for you to even listen to what the president is saying. And you can imagine in the days of fellow Ghanaians what was happening to those people. So it's something that affects democratic participation. And then I've talked about digital literacy. It really affects how people assert their rights, how they enjoy their rights. Because if you don't know how to use the internet, if you don't know how to use digital tools, it's very difficult for you to even enjoy the mobile phone that you have. Someone can have an iPhone and the only thing they are doing with it is taking pictures and making phone calls, sending text messages and all of that. They don't even know that there are tools on it. There are ways where you can actually even, for example, I was explaining to a colleague recently that I was outside the country and I bought medication and it was German that was on it. And then I used the phone's camera to scan the writings and it just asked me if it should translate the text. It came on the screen and I clicked and it translated it for me. So it was like a picture. And if you have this tool and you don't even know how to use it, it's like you have all the tools, but you don't know where to go. It's like you are not making use of the internet and all of that. So it's important that people are trained or their capacity is built on digital literacy or media and information literacy. We know how this misinformation is traveling so fast. It's being used by politicians and other people. People are receiving information, believing it to be true, our aunties, our uncles, and apologies to the aged, but we see that sometimes a lot of the information that is online that is false. For example, WhatsApp message, some information is sent to you, the person believes it to be true, but because they don't really understand the internet, they don't know how to verify the information they are receiving, they are not really able to make informed decisions based on the information that they are receiving. So it also affects democratic participation. And Maud, I know I need to wrap up now, but let me quickly go to the second bit of your question. Which is how to strengthen advocacy with the measurement tools, right? Yes. So the data-driven decision making. I think that the regulator here, apologies for missing your name, but he talked about how, based on what happened last year in March, some decisions were taken and some interventions were made. Some of these development are as a result of data measurements and the reports that are filed from these ones. So it helps to like direct policies and all of that, so that government and other stakeholders know which interventions to take to make the internet space more accessible and affordable for people. It also, helps to identify gaps. It helps to monitor progress that we are all making, and again, it helps informs decision or policy making. Yes, Maud. So digital literacy is important, and then ensuring that this data that is presented is able to inform policy decisions, and also how people use and access the internet. Thank you.
Thank you very much. I'll come to my last speaker, and then I see Mr. Togo. My question is, how can research-driven methodologies such as active probing, passive measurement, and longitudinal analysis be better integrated into national policy and operator practices to improve the reliability of internet measurements in Ghana?
Wow, the question is loaded.
Sorry.
Okay, so we saw in earlier presentation that we do not have a lot of probes in our networks, and it's very critical. If you want to do measurement, we need to have active probes on our networks. We saw some places they have 16,000. Here, I was looking at our data, we have between 200 and 400, or even less than that. So which means that we need to have these probes in our networks, monitoring latency, DNS issues, and give us trace route information. We saw RIPE Atlas giving those information. We need to have this active monitoring regularly in our network, all part of our networks, to have that. Then secondly, we need to have passive measurement tools in our networks that collect flows, network flows, that we can study trends in our traffic that is passing through our network to see where issues are coming from, whether there's some huge traffic that is coming, or there's some anomaly, anomalized traffic is coming through the network, for us to take some action on them. And then put this active monitoring and passive monitoring together and have it over a long period of time. Then we can study the trend of the traffic pattern. Then we'll be able to make informed decision. But before we can get to that point, it's very important that we have standards that we are following, so that the measurement that we are taking is based on certain standards. Not like I have my version of measurement, and then another group also have a different version of measurement. We have a standard measurement that if we say is A, is A, if it's B, is B, then we can now have a base or benchmark that we can say that, okay, this is how the traffic pattern looks like in the country, and this is the trend of events, and then we can all agree on that. Until we have that, then we will not have the correct data to make the informed decision or informed policy that will correct certain things, or for government to invest in certain areas. For instance, looking at our traffic profile, if you look at our traffic profile in the country, it kind of reflects the economy, so to say, because we are downloading heavily and uploading very few. So how can we use this to reverse the trend of things in the country? How can we motivate businesses to host their content locally? Because we need to create that local content. What should we need to do for our data centers to help our service providers to come and host the services in country, and by so doing, driving down the cost of internet, because these service providers are hosting services outside, and we don't have visibility of what is happening. Everybody is flowing with that current. But if you have data to back what is happening, then policymakers can take a decision and come up with policies that will help us host services in country, by so doing, driving down the cost of internet, and also improving the reliability of internet, and not depending on external connectivity. Because as it is now, if we cut off all the 5 cables, will be totally blackout. So we need to use this data to inform policy, to make sure that we are hosting services in country, and then improving quality of service, so that if you are in a remote part of the country, it should not prevent you from accessing the services that you so desire. Thank you.
Thank you very much. Please give my panelists a round of applause. These info, you will not get them anywhere. Any questions for them, please? Oh, that's nice. I think you've done a good job. Is there anything you want to add on?
Yes,
That
yes,
is,
yes, yes.
if there is.
So before we go, you mentioned the difficulty in making calls some years back, but thankfully this has been an issue of the past now, because there is a policy for national roaming within the telecom space. So where there is no Vodafone, MTN, they can ride on MTN to provide service.
Okay.
So if there is at least one service provider in the area, then you should be fine. Oh, it's been there for more than a year, Mr. Regulator.
So it's 1 year.
No, it's been there for more than a year. So
There could be a year and 1 month.
no. It's been more than a year. It could be 3 years, 4 years, 5.
Hey.
But that's a good thing now.
Okay. So if we do not have any, we want to say thank you very much. Well, is the photographer around so that he takes a picture of the panelists? And then we'll have a group photo. And then I would also make a summary of what we have. Okay, so whilst we wait for the photographer, I could start with my submission. One reason why we are here, bringing all stakeholders in one place, is to discuss, definitely when we are talking about the internet, our interest is on cost. We are interested in quality of service. We want to make sure that we are connected, because without it, we are out of touch with the world. But if we want to make sure that all of that happens, our intention is to make sure we should have a standard, as Mr. Togo said. There should be a standard. We are not sort of copying that, oh, maybe this is the standard. When we say something, that's definitely somebody brought it up. Can't we contextualize our own, have it our own measurement standard, which we can use to really measure our latency, measure, our cost, measure this, and see where we are going as a country, so that policies will be clearer. Those who are making sure that the implementations are done. Ghana, we have very good policies. Our issues have always been implementation. Who is ensuring that these policies are adhered to properly? So today, this discussion is something we're going to push out there. Now, another thing about the probes. We all know now that it's important for us to put these probes. Over the years, people have been afraid because they think maybe through that we could have some security attacks. Of course, we all have, when you have your own network, you want to protect it. Security will be one of the major things you'll be thinking about. But here we just want to know, how is our network doing as compared to what is happening globally? That would also help you know, help you know where you are or where you stand. So I guess from this workshop, we've all come to an understanding that having these probes, hooked onto our networks for us to at least know what is happening is important. I'll definitely let Bryce bring the 10 probes that he has. And then we'll see those who will take it and then plug it into their system. I know Leah is online, is ready to ship some of the probes down for us to do it. At least we want to see Ghana. We want to start from somewhere. I have really interest in developing Africa, naturally. But let's start with Ghana. Get these probes in there. Let's see how we are doing in terms of the networks. So since we have the regulator here, at least he's seen what's happening. Civil society, you see, is important. The telcos, you've realized it's important. The academic community is important. Let's also push for that and also make sure that Ghana will not be in the dark, even if the whole of Africa is. We'll start from one country at a time. Thank you very much. I think it's time for our coach. You've done well. Okay, so after the panelists, we all join and take a group photo.
Somehow to come down because I think you are eligible. Okay.
All right. Thank you, ladies and gentlemen. The discussion by our panelists has been very, very insightful, educative. And I, for instance, I've learned a lot. It's going to help me make some decisions and also know the direction for what I do. All right, both academically and in practice as well. So thank you, our panelists, so much. To our online colleagues, we hope you also enjoyed it as we have done over here. Say thank you so much. All too soon, we have come to the end of this program. And I want to use this opportunity on behalf of ISOC Ghana chapter, ICANN, to say thank you so much for participating in this event. We are so much grateful. To all our panelists, we say thank you. for making the time to come and share your perspective, understanding, knowledge, and experience with us. We are so much grateful. So once again, ISOC Ghana chapter, we say thank you very much for honoring our invitation and for participating in this particular program. Thank you and enjoy the rest of your day. Bye-bye.